The dark area that you see that looks like clouds is the formation of new planets. There is one new planet every year in the Milky Way which is formed. This is a view of the Milky Way, not just our galaxy. We're looking at the whole thing here. This is a view from Voyager 4, which has left our solar system and has left the complete solar system area in a view back. It was put together by millions of pictures and compiled by NASA. There are over 100,000 stars, of which we have one star that we'll talk about in a little while, which is of medium size and is at an 11-year low.
Is it the Tabi star?
Tell me again?
Is it the Tabi star or the one star that they
the star that is a medium size is the one we look at every day.
Oh, our sun. I thought you were talking about the other possibility of life, advanced life civilization.
No, no.
Okay, so I know our sun.
We're going to be talking about our sun, and it's at an 11-year low, as you've been seeing in all of the reports. And as we go out, and as you saw with the small solar system that we had spinning over here, we've got Mercury, Venus. We've recently heard about some visits to Venus by other than the United States. Of course, our Earth, which is third in line. Mars, which we'll be talking about in detail. Jupiter, Saturn, Uranus, and Neptune, which was the planet missing on my small solar system in rotation. The Smithsonian dropped it off.
That's the government for you.
Oops, let's see how we go back. Well, we're going to go forward. I can't go back on this one. What we're looking at here is another way to DX. This is a CubeSat. This is a 1-unit CubeSat, a 1U. That'll be critical as we move forward and talk about satellites that can be talked through by amateur radio. This particular CubeSat can either be in a high Earth orbit called a HEO or a low Earth orbit, and we'll discuss the difference in a few minutes. A high Earth orbit means I can talk from St. Louis to Germany. A low Earth orbit means I can talk from St. Louis to California. So it has to do with how high the satellite is as to how much coverage it has. This particular CubeSat, the black area that is shown here, is the solar panels which charge the batteries. And of course the antennas, in this case it's a UHF VHF antenna set. How do we get to space? We've all been seeing a lot of launches going on. And we're going to be talking in detail about launches and how amateur radio satellites as well as other satellites get into space. The top portion of this spacecraft, which happens to be a SpaceX Heavy, the Heavy launch that happened in February, allows, in this case, up to 160,000 pounds of whatever it's taking up into space to occur.
Payload.
Yes, correct, the payload itself. Also, recycling has occurred. That launch that you saw previously cost $109 million to launch. Typically, that launch in the past, when we didn't recycle portions of the spacecraft or the rocket, would have cost $150 million to launch. By recycling, SpaceX in this situation and Blue Origin are recycling their spacecraft pieces up to 10 times, saving about $30 million a launch. So the cost of getting into space is going down. This is an Electron rocket. This is out of India. The Electron rocket is designed specifically to launch up to about the size of a standard two-door refrigerator. On this particular launch, there were 19 CubeSats deployed in low Earth orbits. Low Earth orbit is between 240 and 270 miles above the Earth. Question?
Just a quick question. Does space begin at approximately 150 miles?
No. I believe, begins at 250,000 feet. So if we divide that by 5,268, you can do the math. Okay.
Oh, those little satellites that they launched for the repeaters, are those actual this size when they're floating in space? Are they actually that small?
Julie, if you could wait, you're getting ahead of me.
Sorry.
How do I back up with this? Can you show me, please?
Yeah, I think you just hit the back button. Or I'm sorry.
I'd like to go back one slide. Oh, there we go. Thank you.
Yep.
Okay.
arrows.
Okay. Thank you very much. We have a company here that we're all familiar with, formerly McDonnell Douglas, now Boeing. They are involved actively in space. This is just a summary of the products that they publicize. I'm sure there are many others that are top secret that they're doing for the military that we have no idea what they are. They have a lot of items on the International Space Station. They're involved with building satellites for launch for the federal government and many other departments. X-37B was the replacement for the space shuttle. We're going to be talking about that in a little while, and we're going to be talking about ARISS, A-R-I-S-S, and contacts. The Starliner has just had a delay as of this afternoon till August to go mate up with the International Space Station and see if it can transport astronauts back and forth without the use of Russia. This is the space launch system, which is called the Launch Alliance. This is a combination of Boeing and it escapes me right now, but they have a partnership with Lockheed, and they are putting together rockets, heavy rockets, so that they can launch into low Earth orbit as well as high Earth orbit and into geosynchronous areas.
It's a United
United Launch Alliance.
Yep.
Additionally, this is the Phantom Express. This is another alternate for the space shuttle, and we'll be talking about that more in a few minutes, because it is going to affect space and what we are doing around the Earth. The first CubeSat put up by an amateur radio operator was in 1961. It's called Oscar 1. It was a repeater. You could talk to it and you could hear back from it. It's put together by a professor from the University of California. He had at that time said, everything is getting smaller. Let's go ahead and put it into a small container and let's get a launch. In this case, it was launched as a ride from another rocket which was delivering a larger satellite. So it was put out into space and operated for approximately 10 years. Information's down here on that. CubeSats are our method of communicating for DX. A CubeSat is 4 inches by 4 inches by 4 inches. It's this big. I won't pass this around, it's too hard to handle, but this is the size, I can hold it in my hand, of a CubeSat. Oh, great, thank you. You can see the size of a CubeSat. Additionally,
That was floating in space in the actual size.
well, we'll talk about that.
And yours
Another actual size CubeSat is shown right here. Thank you. Yeah, we can put those down now. Thank you, John.
That's like trying to aim on doing it.
Now, a minute. Yes, please.
So do CubeSats need any kind of protection against like cosmic rays or?
Yes. And we'll talk about radiation in a little while. Yeah.
So
Yes.
you're telling me that that is the actual size that's floating in space? Just it?
Let me comment. The reason we can actually make satellites smaller than 4 inches by 4 inches by 4 inches and have them operate. But the Air Force can't track them. The Air Force has to be able to track a satellite for it to get a launch permit. We'll talk about space junk in a little while, but there's a requirement on all satellites, including the CubeSat, that it has to be able to deorbit and burn up on re-entry within 25 years. It's a requirement that was put on 3 years ago because of the 20,000 pieces of space junk that we have up at this time. Plus, the Chinese blew a satellite up over China, specifically so we could not put a spy satellite in that area. It would be hit by debris. So there are other reasons that debris occurs. On the side of this satellite, you'll see the antenna is wound up. This one hasn't yet been launched. As you can see, it's on a table. What they use is fishing line. And that fishing line holds the antenna in place. When it is launched, and we'll look at some launches next, there's a small heater that turns on, melts the fishing line, so the antenna can go boing and be in position. It's another satellite. As you can see, it's a display satellite. It's got plexiglass so that the solar panels doesn't get fingerprints all over them. This is a 9U satellite. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means it's 9 times 4 inches, and then it's 4 by 4. That's what a 9U is.
Could you, for the benefit of those of us who do not see, explain that a little bit?
Yes. I mentioned before that a 1-unit satellite is 4 inches by 4 inches by 4 inches. So it's 4 inches tall, 4 inches wide, 4 inches deep. A 9U is 9 times 4 tall, so it's 36 inches tall by 4 inches by 4 inches.
No longer a cube.
Yes,
So that's the actual dimension that's floating in space?
yes.
And we're expected to get that like a needle in a haystack?
We'll talk about that.
Oh, sorry.
Okay?
It's
You're getting ahead.
I'm sorry.
What is a basic CubeSat? As you can see here, this is a breakdown of what one CubeSat is. You'll notice on the very top there is a solar sensor. That means it's sensing where the sun's at. The solar panels are the black areas and are all around it. So any direction, or even if it's spinning, it's still accumulating photons to convert into electricity, and the average output is 4.5 volts per solar panel. I've taken delivery of all the components necessary to build a 1U CubeSat, and I have it at home right now. Correspondingly, this particular one, as you can see, has a tether reel motor. In many cases, multiple satellites are put up that are in formation. And it used to be historically they were tied together with a cable or some method of keeping them close to each other. The newer models have ion engines, which means they push out electrons and they can move themselves to the left, to the right, to the top, to the bottom, and they communicate with up to 10 satellites by lasers between them, just like we do with fiber optics for internet. Except they're in space and they stay in a formation. Each one has a specific job to do. So this shows some of the detail of that, and these pictures and these items are available on the AMSAT website. You can get a lot of information. So I'm not going to go into any more detail just because of time. Let's talk about how a CubeSat works. We're all used to DXing, and hopefully, you know, we've got a lot of countries up on the wall where we've talked to people and we get cards back stating that, hey, you know, this is kind of neat. You know, I talked to somebody in Finland. Wow, really neat. Well, it's nice to do it like I'm sitting next to you, like I'm on the repeater on the 8.5, saying, hey, let's talk. As you'll notice the arrows here, as we're talking to this in the UHF range, 432.135 to 432.175, that's right, the new receivers and transmitters compensate for Doppler shift. So you can stay on one frequency. As this comes in, it's processed and it goes to the output side, which is going out on VHF 145.85. That sounds relatively close, 85 anyway, and 145.950. So it's giving you a little bit wider bandwidth, so you don't have to worry as much about Doppler shift. Because remember, if this is in a low Earth orbit, it's moving at 6 miles a second, which is 17,400 miles an hour, same speed as the ISS is moving. So it's a repeater much like we have here on Earth, except it's miniaturized, it's a lower output. We're probably putting out 50 watts on the 8.5 repeater?
About 14.
14 watts on the 8, okay. This will put out about a half a watt to max 1 watt. In some cases, they put out 250 milliwatts, quarter of a watt. But remember, there's not much between you and 250 miles away. Here's how they're released. What you're looking at is a piece of the International Space Station, and what you're looking at is a launch device here, and we're going to talk about that in a little more detail. You're all familiar with the jack-in-the-box. Oh. These are spring-loaded. There's a spring in the back. Once you've released it and the door is open, it goes boing out into space. That's how they release them. This was originally devised by a professor at the University of California, San Diego, who is a CubeSat builder. He's the one that came up with the idea of 1U.
It looks like
You can't have a Boeing in outer space, there's no air.
That was for demonstration purposes.
And he's got airlock.
Here's that 9 unit coming out right now. Notice it's already deployed one of its antennas.
the baby. It looks like the mama's letting his babies out in space.
There it is, on its own. Now, once you get it into the orbit, it stays in the orbit, typically. There's a certain amount of drag involved, and if you're concerned about drag, they put on these small ion engines, or they have what's called a coal gas thruster that they put in that eventually run out of fuel. As the drag continues, these will deorbit and burn up before they get close to Earth at all.
Wait till they get fusion power. Oh, it changes a whole new set of things.
The weight of these satellites, a 1U typically weighs 12 pounds. This 9U probably weighs about 60 pounds. So we're not talking about a whole lot of power to get them into space. So they often take rides. A lot of the big rockets, as they launch, they put ballast in, which means lead weights and stuff, because they have to stay in a certain dynamic range, much like an airplane flying. It's got to stay within a utility category range. Instead of adding weight to it, why not add some CubeSats and the launchers? So some of these amateur radio satellites have gotten free rides, and other ones have cost $100,000 a ride. This setup that you're seeing here, and it's on one of the boards as well, as you can see, is my setup at home. You can see there is, it might be hard to see, but there is a UHF antenna, which is a 30 dBi gain, and a circular polarized antenna, which means as the radio waves come through the atmosphere, the Earth is turning, the spacecraft is moving, you tend to get a spin.
Is that on a rotator?
This is on a Yazoo rotator, which is elevation, and it will go over the top if it needs to follow a satellite,
Automatic tracking.
as well as azimuth from 0 to 360 degrees, compositing. Cabling is set up so it doesn't get itself tied up. And this is a Kenwood TS2000 tied with the rotor controller, an interface box to allow the computer to control the rotor and the computer to control the radio. The program in the white area that you see here, this is SAT PC 32, which is available from AMSAT, by the way, for 50 bucks. Actually allows you to select the satellites that you want to track, and you can track up to 12 satellites simultaneously with all of their views. At the bottom of the screen, which is not apparent, it lights up and it talks to you and it says, satellite in view. When it's exiting, satellite out of view. And along the way, you can see the tracker and you can see the antenna start moving. And if you've got the radio turned up, if you're turned into a beacon, you can hear the beacon. If you want to talk, you can talk. Now, when you talk on satellites, you don't waste time. You say N0TJD, and somebody else comes back. The pass time, meaning how long it is from beginning to end, we're going to talk about in a few minutes. All of this information is available to you, and at the end of the presentation, there's some handouts up here that will assist you if you're interested in DXing through the birds, as it's called.
Tom, do you not exchange grids anymore?
You put in your grid square so that the system knows where you are, and it then tells you as the pass occurs at the horizon, from horizon to horizon.
No, whenever you're doing exchanges, your call and then your grid.
You look up the person's information on QRZ.
Oh, okay, gotcha.
Okay, and sometimes you can have a short conversation. A low Earth orbit, typically, if you're between 40 degrees, 90 degrees, and 135 degrees in this wedge, will take about 9 minutes. If we're talking on AO07, which is in a high Earth orbit, you've got about 20 minutes of talk time. And it's a much larger area, and we'll talk about that in just a minute. Questions? Should I ask any other questions at this point? Yes?
What do these cubes cost?
The frame itself, the metal frame that you see, is $6,500. Okay? Then the rest of the parts inside. My CubeSat, because it's a demonstrator CubeSat to take to meetings like this once assembled, is I used a 3D plastic print. So I had the actual frame for this printed in 3D. It cost 27 bucks. So 6,500 versus 20. Now this won't go into space, but the whole point is that we'll talk in a little while about why we're doing CubeSat simulation. schools have a 40% failure rate in building satellites. We're going to allow them to practice with simulators, get good at it, and then build a real thing so they can put it in space. But we'll get to that. What we have here is the discussion about a handheld antenna. John, would you help me? And Kyle, are you available to assist? If you want to get in the middle there, and Kyle, if you could hold the radio. It weighs about 4 pounds.
Oh, okay.
If you guys could kind of go between the groups over there. There's a book that's available from AMSAT. If you want to buy a hard copy of it, it's 15 bucks. If you sign up to become an AMSAT member, you get a free digital copy of the book as part of your thank you for signing up. That's a new program that AMSAT has out right now. You're going to be getting a copy of different cards like this. They're actually paper copies. And what's occurring is this shows you all of the satellites that you probably want to talk through, so that gives you the frequencies. It also gives you the tone. Often satellites will have 67 hertz as their tone. And the reason for that is so that somebody's not randomly turning them on transmit-wise and they're using up all of their battery life. This is showing just a partial page. The page is actually longer than this, but you can see all of these satellite names here. Okay, and correspondingly, here's AO95. It's having a problem right now. There's only one beacon contact on it. This shows that it's in good stead. Transponder repeater active shows how many times it was talked to. This is between February 15th and February 10th. And if you go over this with your mouse, it'll tell you who talked to it. This particular individual is JA7. Okay? JA7 is in, I think, Japan. So he was talking to someone on this particular satellite, on the date, on the time. Notice it's all universal standard time. When you go onto this web page, which is a free web page, and you're going to receive something that says www.amsat.org, you'll come up and you just go to predictions, and it will take you into the pages I'm showing you right now. We've selected AO95 and said, we'd like the next 10 passes. EO48TO is my grid square, and I've added to it so that it's exactly where my house is at in that grid square. So it will automatically calculate for you if you don't know your exact position. And I'm 190 meters above sea level. You can figure that out. Just look on your GPS in the car or someplace else and it'll tell you how high you are and convert it to metric. Now we're going to say predict. And it's going to give us, in this time frame, the predictions from February 16th through the 17th. In this case, these are the next 10 times that satellite's going over my house or within the area that I could talk to it. And let's look at what we have here data-wise. It's telling us how long it will be over, 11 minutes and 56 seconds. The universal time it's going to start, the universal time it's going to stop. What the heading is going to be when it comes up, when it gets to the horizon coming towards us. What the heading is going to be when it gets to the other horizon. And it'll tell you what its elevation is. What you want to do is pick something that's above 40 degrees. So here's a 68 degree. 15 degrees. And let's see what we have, 304. So I use a yardstick. And I set the yardstick down, and John and Kyle are going to be our coordinators. You hold that.
Okay.
You'll notice we're using a 5-watt handheld radio for this, which is set up so that I can see UHF and VHF. You do need that capability, or you need to use 2 radios. So this is a 2-person operation. I recommend you have 2 people. One messing with the radio. Okay, so the satellite is coming across, and he's going to go faster than he should, because this normally you're here, and it's a total of about 10 minutes before you get to the other side, the other horizon, while he's listening and transmitting. In this case, we're not on and we're inside a building. And if he's got a problem, he's going to rotate that antenna in his hand so that he gets best signal, because that is not a polarized antenna. So he's giving it a twist, so he's getting the signal just right. A little wrist action. Thank you, guys. If you could just set it back down over here. Any questions about that before I move on to ARISS?
That's,
Yes.
You mentioned that there's a motor to orient the solar panels. What about the antenna? It's, from my experience, it sounds like some of the FM CubeSats, maybe they're tumbling or something, because the signal kind of comes in and then goes out.
That's correct. They are tumbling. Unless they have the CubeSat that I showed you that was in pieces, it had a magnet built into it. That magnet is supposed to keep it pointed at the Earth. But most CubeSats are tumbling. So they vary in and out. The recommendation by NASA is that you have a polarity switch even if you have a left-hand polarized antenna that you're using, which means it has horizontal and vertical and horizontal. What they want you to do is flip back and forth so that you get the right sequence. So the answer is yeah, if you were spinning your antenna to match the signal, it would sound better.
I have an incredibly simple antenna. It works, but it can't do that.
Okay. Yes?
If you exhaust your 9-minute period, how long in time would you wait for another episode?
If it's in low Earth orbit, 92 minutes. But it might not be close enough to get a good pass. Every 92 minutes it moves 1,700 miles. So it might be tomorrow before you're ready to do it again. But we'll talk about that next, and that has to do with the International Space Station as well. The Internet... I'm sorry?
There's another website that has the next 6 hours. If you want to see, with the AMSAT site, you can check one particular satellite at a time. It's, I think it's ny20.com. He has a 6-hour, he shows you all the satellites in the next 6 hours, and based on your location.
IRA has a website that you can put on your telephone that allows you to see all of the CubeSats, or all of the satellites that are available for amateur radio for the next 6 hours. And maybe at the end of the presentation you could come up and speak so everyone could hear you, or what it is, okay? Thank you. Yes?
you know what would be really neat? If you had repeaters that we could link from our house, and that repeater would have an antenna that would track the satellite, and we could talk to the satellite from space like we're normally doing, like as if we talk to the repeaters here in the club repeater.
Thank you.
You're welcome.
Okay, let's move on. The International Space Station. We do International Space Station school contacts. Thomas Labor spoke to you last month about the contact coming up at his school where he has 600 students. It will also be broadcast to the other schools in his district. So there will probably be 1,200 students listening in. Part of my job as an ambassador and educator with AMSAT is to work with schools and assist them in applications and the appropriate hardware and radios and ham radio guys that know what they're doing for this to pull this off. If you are interested or have a school that you think might be interested in doing this for their students, I would be happy to talk to their principal and science teacher. There are some cards up front with information about who I am and how to reach me. And on the back of it, as a bonus, you get a picture of a CubeSat. So if you know of any schools, the whole intent here is to try to get 6th, 7th, and 8th graders interested in taking chemistry, physics, and math in high school so they're eligible to go on for a science major. Why? Why is NASA so interested in this? NASA hires 1% of science and engineering students after graduation or after they have their master's or PhD. To get that, they have to have 100,000 students. They get 1%. They hope they get the best and the brightest. 1% means you have to graduate 100,000 U.S. citizens, because remember, this is a defense contractor. So they can't be from another country. The whole intent of this program is to allow the International Space Station people on a scheduled basis to talk with the students and to get them excited and to change the curricula in school to say, this is really neat. Moreover, we're going to talk in just a few minutes about Mars. They're going to need at least 1,000 people 24 hours a day in 3 locations around the world just to track the people on their way to Mars and to be able to communicate with the people who are setting up base on Mars. And we'll get into that in a few minutes.
Tom, a question. These students that talk with the International Space Station, are they limited to that 9-minute window?
They are. So what they do is, let's say that we have 600 students coming together, like Tom has at his school. They select a total of, in his case, 16 students. Each one will have a set of questions that is their class has come up with that are acceptable to the astronaut and sent to the astronaut ahead of time. Now, they're not told that. But we don't want the astronaut to balk, okay? And we know who the astronaut is already that they're going to talk to. During our conference calls with NASA, they told us. So we knew who we're going to be talking with. Correspondingly, Thomas will select the kids that are not afraid of the microphone and who are capable of being able to speak on behalf of their class. They will then rotate through, but it'll be on behalf of all of the 600 kids behind them. Yes, sir.
Just to feed off of that, we've got rehearsals because our contact for Woodbridge just south there is going to be in the autumn. We've started our rehearsals now, and they're going to go on through until the end of the year with some of the students that we've cherry-picked and identified. Not all of them are going to make the cut, because he's right. Some of them are going to, they'll push the think thing, where they stand in front of the microphone and they just can't speak. We can't have that because there's so little time. We have to have it like an assembly line.
Thank you. Okay, this is the motley crew that they're going to be talking with, okay? It just goes to show you that we're going to talk a little more as we get into the Mars side of this as the DNA changes by being in zero gravity. Again, you can see with the ponytail, zero gravity. And you'll also notice there's a small plane hanging off of this. John, would you assist again, please? And if you could show it here, and then we'll show it on the other side. In the very center of this poster, you'll see the Dream Chaser. See this airplane? As he's walking across, I'll explain what it is. The Dream Chaser is a replacement for the shuttle. The shuttle was taken out of service because this cell phone has 1 million times more power than the biggest computer on the space shuttle. It was obsolete. Thank you. The Dream Chaser is going to be the primary vehicle for our new Space Force that you've heard has been released, like the Army, the Coast Guard, and all that blah, blah, blah. I don't know any more than I'm telling you right now, except it's designed to be launched with a standard rocket in the fairing on the top. That standard rocket will take it into space. It has its own rocket then to continue on. And when it lands, it can land on a 7,000-foot runway, such as St. Louis Downtown Airport Parks. It doesn't require a 14,000-foot runway and no power coming in like a gliding brick. It can be turned around in 15 minutes, put in another fairing, and be on its way to space. There's another picture of it. There are currently 8,000 active satellites around the Earth. They're not all amateur radio satellites, but the satellites that you can talk through right now numbers 195, and this is a complete listing of probably 40 satellites per page right here. SpaceX received an approval and a requirement. They have to have 7,368 satellites launched within 36 months. The total number that need to be launched is 11,000 satellites. They're going to be in low Earth orbit, so there's not a latency problem. We'll talk about that in a minute. This will be internet for the world. They expect a revenue path to be $30 billion a year for them.
Are we talking about advanced?
Once they're up. This is a picture of what those satellites are expected to be. They'll be spaced out more than this. But there will be ground stations that will go up effectively, and because they're only 250 miles up, you don't have the delay problem like you do with a Hughes satellite that's sitting at 22,400 miles from the center of the Earth, of a 2.5-second delay, where you have to have a delay compensation if you make a phone call. These are close enough that the latency time is only 20 milliseconds. This is happening. It's been approved by the FAA, the FCC, and NASA. This is what 8,000 satellites look like around the Earth. We're not the only ones putting up satellites. China launched 25 CubeSats about a month ago. And by the way, they didn't go and get the right frequencies for those CubeSats. So they're now interfering with a lot of other stuff. This is all supposed to be a coordinated effort. So if you get players that aren't coordinating, there's a problem, boys and girls. Yes, sir?
Is there any threat or fear of collision?
The answer is they're all going at the same speed in their orbit.
But they could go in reverse also.
We're not going to get into that conversation right now. Okay, let's talk about geostationary and geosynchronous. Geostationary means dish TV, direct TV, where they stay where they're supposed to be. They sit there and they do like a little figure eight, but they're not moving far enough out of range that you can't catch it on your dish in the back that's screwed down so that it's looking directly at that signal, right? Okay, that's geostationary. Geosynchronous means they can move around a little bit. We have a new satellite going up through AMSAT, actually through one of the universities, in conjunction with AMSAT, which is being put up specifically for the forest fires in California. They're expected to be a 300% increase in forest fires in California. About 5 years ago, there were 19 firefighters that were trying to use their handheld, their HTs, to talk to a repeater, but there was a hill in the way. They didn't know a backfire was coming up. And they put their silver blankets over them, but it incinerated them anyway. So this is a situation where there was enough pressure put on to build a satellite. It'll be connected with a geosynchronous satellite of the Air Force, so it has power. And I was at a meeting about 4 years ago. Vanderbilt was showing the camera. The camera, they were messing with it, some physicists, and finally they hit the button and it went on. And you could see the pores on the surface of your skin. It was a 100 million pixel camera. It's intended, if you don't have smoke, to look down and act like a tower, effectively, looking straight down on the fire to say where it's going and what's happening with it. Plus, it's designed for the HTs to be able to talk through it. Now, latency problems are not a problem, because if it's a simplex, you talk up, comes back down, okay? So you listen. So 2-second delay is not a big deal. But if you're doing a continuous conversation with a telephone, it is a big deal. So that is being set up to be launched in the near future. Those satellites are sitting 22,400 miles from the center of the Earth. The Earth is 8,000 miles in diameter. So subtract 4,000 miles off of that, and that's the distance they are from the surface of the Earth. Okay? You probably all had the opportunity to watch the SpaceX launch and see their Starman in action, or maybe lack of action. The SpaceX device, our heavy rocket, was put up as a test to make sure they could really do this. That was the very first rocket we saw take off in the very beginning of this presentation. Our mannequin now has been around Mars and is coming back to the Earth and is about to go around the Earth and go back around Mars again. So that's a very, very long elliptical orbit that it's in at this point. And again, just a picture of a CubeSat. This is some of the satellites that have been up for years and years, and as you can see, these are approximately 13 seconds, 60 seconds, 15 seconds. They're different distances apart. They're designed for agriculture and moisture. They have been up for approximately 15 years by the federal government. They evaluate every 2 weeks the current situation with moisture and crops for the world. These are working in conjunction with each other. This is AO07. It was launched about 7 years ago by AMSAT, and it is in a high Earth orbit. It's more expensive to get high Earth orbit, but it has a much bigger footprint. So you can, as I said, I could talk from St. Louis to Germany and things like that. We can't pass satellites without talking about our scopes. This is one that you hear about all the time. This is the Hubble telescope. Hubble is from Missouri. He was born and raised near Lebanon, Missouri. Okay, his dad wanted him to be an attorney, got a degree in law, but he wanted to be an astronomer. He is the astronomer who figured out that our solar system is expanding. So they named this after him. Let me go back. Some of the images are extraordinary. We don't have the resolution necessary at this point, but there are 1 billion galaxies in this picture. How can we be alone?
We're not.
This is kind of what our Milky Way looks like, but this is another galaxy far, far away, like we hear from Star Trek and a number of things. The plan is to launch from Earth's moon for Mars. Why?
Gravity.
If I weigh 200 pounds, which I do, I'm sorry to say, I should weigh less, but I don't. I weigh 14 pounds on Mars. So we can take multiple ships up, accumulate. We don't need as much power to get off of Mars.
You get more speed too.
And we can use the big rock that we live on, called the Earth and its gravity, as a slingshot. Maximum speed right now is 56,000 miles an hour. We don't have a warp drive. They're working on it. Here's the red planet that they want to colonize, and we're going to be talking about that next. Here's the moon. There's been a lot of DNA change work done. You're familiar with our astronaut who was up on the space station for 50 weeks, not 52. When he came back, there were 14 changes in his DNA, protein changes in the DNA. 7 of them have not changed back. He used to be an identical twin. He's not an identical twin anymore. He's also 2 inches taller than his brother. And he's got to wear glasses. If astronauts stay on the space station longer than 90 days, their eyes go spherical. Your eye is actually a kind of egg-shaped. It allows the lens, it focuses for the egg-shapedness of your eye, okay? As we get older, yeah, we probably do need glasses to compensate, but that's just due to inelasticity of the eye itself. Well, when they go egg-shaped, you need cheaters to be able to do the experiments that they sent you up there to do. So they send them with a pair of glasses before they leave Earth, anticipating what their needs are going to be, because they go up for 6 months tour of duty. That's one of the changes we're aware of. They also get taller. There's also a bone density problem. That's why they exercise so much. So if we start colonizing worlds such as Mars that are only 38% of our gravity, what's going to happen? As I said, Moon will be one of the launch points. NASA has stated that, they did this a few weeks ago, they've changed this prediction now, that we will have people on the Moon and a base on the Moon within this year. They've changed that to 2023 because they know they can't do it. But this slide was made up before they changed it. China has landed on the far side of the Moon. NASA was like, oh my God. Russia, I'm sure, was saying, oh my God. India will probably be the next one to land on the Moon. This is the main landing device, and you see these 2 runners? It's kind of like putting rails on the back of your station wagon and rolling your lawnmower down, okay? Because this is what rolled off of this device that was landed. This is the base station. This is their rover on the far side of the Moon, and to my knowledge, they didn't find any aliens.
When they go to Mars, they can also repair the rover there on the surface as well.
Thank you. Thank you. We'll talk about Mars in a few minutes. If you're on the far side of the Moon and you transmit, where does your signal go? It goes out in space, right? So how do you get information back and forth, and how do you tell these little devices what to do? CubeSats.
Repeaters again, basically.
This is a CubeSat, and typically you're going to be using X-band. We'll talk about that. X-band is 5-10 gigahertz. And UHF from the actual CubeSat to, in this case, the Chinese base station and rover. It is also searching for water. These CubeSats will typically have a camera on the bottom and a camera on the top. Now we're moving to Mars. This is our InSight lander, and you'll see that it talks through Marco A and Marco B. This is the device they put up there to determine if this Mars had tectonic plates similar to what the Earth has. And the drill got stuck. I think they probably got that fixed, but this drill that was drilling down 15 foot got stuck. This is the actual seismograph when they put a charge off to be able to see what it is. Marco A and Marco B go around Mars so that at all times NASA can communicate with its device. You can see this is not a real big satellite. It's about the size of a briefcase. It does have a high gain antenna on it, which is similar to a dish type antenna, except it's a flat panel like you'd use for a radar system. Solar panels to charge the batteries. Remember that Mars gets half the sun that we get on the Earth. This is technically what we have here. Notice there's coal gas thrusters. We have a UHF antenna on the bottom, which is how it communicates with its InSight on Mars. And you can see here X-band transponder. We'll talk about that in a minute. Battery assembly, which is being charged. And this is how it works. Information is sent up and back 5 to 10 gigahertz and is communicated with the InSight lander. Data sets. At the end of the presentation, you'll be able to pick up this sheet. On the top of it is a website. That website, let me get my sheet out here. And I'll pass this around for review, will give you a weather report and graphs of how the weather is doing, barometric pressure is doing, and the winds are doing on Mars. So you can get a daily weather report from Mars. If I can pass that around. Okay, let's say that we leave the moon on our way to Mars. We swing around the Earth. We get a lot of momentum going. We're at 56,000 miles an hour. We got to go 238 million miles. It's going to take 6 months if Mars is very, very close to us, such as what I'm showing you right here. It's 238 million miles between the Earth and Mars. By the way, the size of Mars is about the same as our central core of the Earth. So Mars is a smaller planet. The amount of radiation coming off of the sun is a lot. Cosmic radiation is one of the major concerns that NASA has in talking to the Goddard Space Center for the astronauts. My specialty is radiation. And this accumulates over time. We don't want people to arrive to die on Mars because of radiation. There are a lot of lava tubes on Mars. 2 million years ago, Mars had an atmosphere very similar to the Earth at this time, including vegetation. And for whatever reason, they blew it away, and all of the surface water evaporated. They would melt all of the water on the North Pole and the South Pole of Mars. There would be 30-foot deep water on all of Mars, but it would then be evaporated into space. So you got to think about that in global warming. We're on that same path. Humans to Mars. Projected spaceship landing area. Go back. See if I can get this running here. Let's see if we can get this. What's that?
Had trouble playing media.
On this? Okay.
Yeah.
QuickTime is not available. Okay, I'm sorry. Okay, what we're proposing are the pictures you would have seen in the video, which is not, I had to put a jump drive on this computer to show you this tonight, is a build out up to 1,000 people living on Mars. They're looking at commercial companies such as SpaceX, Blue Origin, Boeing, moving people back and forth. Remember, these are companies. NASA's original thought was to take 34 people up there and leave them. You can't make a living doing that. You've got to have a transportation system going and coming to be able to make a living. So all other commercial vendors are talking about moving people back and forth from Mars. To check the weather, which we just talked about, please come up afterwards and pick up a sheet, and it'll give you the appropriate website to check the weather on Mars. It's kind of a fun little thing to do. It gives you a display, gives you a very nice picture of the InSight lander. Yes, sir?
How are they going to handle the temperature on Mars?
Well, if you look at
Inside all the time?
the answer is it's according to whether you're in the lava tube or not. They're talking about building habitats inside the lava tubes, and the reason for that is that would reduce the amount of cosmic radiation because they don't have a Van Allen belt like we do. They have a magnetic field, but it's only like 15% of our magnetic field. If you can imagine it, you can do it. And that's what's been happening for many, many years now with our AMSAT people, with NASA, with everyday schoolwork. If you want to stay close to the future of amateur radio, we recommend you become an AMSAT member. It's $44 a year. You get a free digital copy of Getting Started on Satellites, which is a $15 item. Tonight you're going to receive, please come up and pick one up, all of the active AMSAT satellites, including the International Space Station, what frequencies they're on, and even with a standard antenna, if the space station is coming over and within between 45 degrees and 135 degrees, 90 being straight up, you'll be able to hear the the information coming through for packet so that you know that you just heard it and it's on time. That's one of the benefits of satellites. They're extremely accurate as far as when you expect them to be there and when it does occur. Also, there's a journal And there's a few copies of the journal up here to look at, but every 2 months you get a journal which, if you like technical information, comes to your home. And it is quite good. I enjoy reading through it. DXing through the cubes. You won't have to worry about where the sun cycle is if you get started with that. Again, I'm Tom Dougherty, NØTJD. I live near Kirkwood in Warson Woods, and I'd be happy to entertain any additional questions that you might have now. And thank you for listening to me this evening.